This is Miss Sec. This lesson is difficult, which is why I broke up the class and I'm only teaching it to one group at a time over 4 weeks. Make sure that you have your math journal and a pencil or a piece of paper and a pencil before you watch this video. Okay, let's review vocabulary. The variable is a letter that represents an unknown number. Constants are numbers that have no variable, and a coefficient is a number that multiplies a variable. Let's review the difference between an algebraic expression and an algebraic equation. An algebraic expression has variables, coefficients, constants, operations, but an equation has all those things and an equal sign. Let's review solving equations with variables on both sides. When you have equations with variables on both sides, you have to bring one of the variables to the other side to be able to solve it. This is an example of distributive property. This is a combo meal. So this is 2 tacos and a soda. This 3 on the outside the parentheses represents that there are 3 groups of 2 tacos and a soda. So there's 6 tacos and 3 sodas. Okay, today we're talking about 3 types of solution. One solution is when you get an answer for x. You can see that it's graphed at a point. No solution is when the 2 lines never touch. They're parallel, and you see 1 can never equal 2. That's why it's no solution. And infinitely many solutions is when the 2 lines overlap each other. So you know you have that kind of solution if you get a number equal to itself.
Determine the number of solutions for each of these equations, and they give us 3 equations right over here. And before I deal with these equations in particular, let's just remind ourselves about when we might have one or infinite or no solutions. You're going to have one solution if you can, by solving the equation, come up with something like x is equal to some number. Let's say x is equal to, if I want to say in the abstract, x is equal to a, or if we actually were to solve it, we get something like x equals 5 or 10 or negative pi, whatever it might be. But if you could actually solve for a specific x, then you have one solution. So this is one solution, just like that. Now, if you go and you try to manipulate these equations in completely legitimate ways, but you end up with something crazy like 3 equals 5, then you have no solutions. No solutions. And if you just think about it reasonably, all of these equations are about finding an x that satisfies this. And if you were to just keep simplifying it and you were to get something like 3 equals 5, and you were to ask yourself the question, is there any x that can somehow magically make 3 equal 5? No x can magically make 3 equal 5. So there's no way that you can make this thing be actually true, no matter which x you pick. So if you get something very strange like this means there's no solution. On the other hand, if you get something like 5 equals 5, and I'm just overusing the number 5, it didn't have to be the number 5, it could be 7 or 10 or 113, whatever. And actually, let me just not use 5 just to make sure that you don't think it's only for 5. If I just get something that something is equal to itself, which is just going to be true, no matter what x you pick, any x you pick, this would be true for, well, then you have an infinite solutions. So with that as a little bit of a primer, let's try to tackle these 3 equations. So over here, let's see, maybe we could subtract, if we want to get rid of this 2 here on the left-hand side, we could subtract 2 from both sides. If we subtract 2 from both sides, we are going to be left with, on the left-hand side, we're going to be left with negative 7x, and on the right-hand side, you're going to be left with 2x. This is going to cancel, minus 9x. 2x minus 9x, if we simplify that, that's negative 7x. So you get negative 7x is equal to negative 7x. And you probably see where this is going. This is already true for any x that you pick. Negative 7 times that x is going to be equal to negative 7 times that x. So we already are going into this scenario, but you're like, hey, so I don't see 13 equals 13. Well, what if you did something like you divide both sides by negative 7? Negative 7. At this point, what I'm doing is kind of unnecessary. You already understand that negative 7 times some number is always going to be negative 7 times that number. But if we were to do this, we would get x is equal to x, and then we could subtract x from both sides, and then you would get 0 equals 0, which is true for any x that you pick. 0 is always going to be equal to 0. So any of these statements are going to be true for any x you pick. So for this equation right over here, we have an infinite number of solutions. Let's think about this one right over here in the middle. So once again, well, I'll do a little bit different. I'll add this 2x and this negative 9x right over there. So we will get negative 7x plus 3 is equal to negative 7x. So 2x plus 9x is negative 7x plus 2. Well, let's add, actually do that in that green color. Let's do that in that green color. Plus 2, that's this 2. Now let's add 7x to both sides. Well, if you add 7x to the left-hand side, you're just going to be left with a 3 there. And if you add 7x to the right-hand side, this is going to go away, and you're just going to be left with a 2 there. So all I did is I added 7x to both sides of that equation. And now we got something nonsensical. I don't care what x you pick, how magical that x might be, there's no way that that x is going to make 3 equal to 2. So in this scenario right over here, we have no solutions. There's no x in the universe that can satisfy this equation. Now let's try this third scenario. So once again, maybe we'll subtract 3 from both sides just to get rid of this constant term. So we're going to get negative 7x on the left-hand side. And on the right-hand side, we're going to have 2x minus 1. 2x minus 1. And now we can subtract 2x from both sides. To subtract 2x from both sides, you're going to get, so subtracting 2x, you're going to get negative 9x is equal to negative 1. Now you can divide both sides by negative 9. And you are left with x is equal to 1/9. So we're in this scenario right over here. We very explicitly were able to find it.
Okay, now I'd like you to take a few minutes and solve these 3 problems before I go over the answer. Okay, so if you haven't finished solving the problems, go ahead and pause the video. Okay, now subtract 4x on both sides in number 1, subtract 7x on both sides in number 2. In number 3, you need to combine like terms. So 4x plus 3x is 7x. Now we have a 2-step equation in number 1. We're going to add 2 on both sides. This one is all real numbers, infinitely many solutions, because negative 2 is equal to negative 2. We're going to subtract 7x on both sides for number 3. So add 2 on both sides. It's going to be 3x is equal to 6. This is infinitely many solutions. Now, it's not possible for negative 2 to equal 4, so it's no solution. So x is equal to 2. That means this is one solution, and we have our answers. I'm waiting for a video.
Different types of solutions for equations. A la Schmidt. All right, equations come in all different shapes and sizes, no matter how much they try sticking to their diets. All right, well, some equations have no solutions. These are called contradictions. No, they're not. Yes, they are. No, they're not. Yes, they are. All right, for instance, the equation x plus 1 equals x plus 5 would be a contradiction because no value of x will make that equation true. Right? It would be like saying a zebra is the same thing as a lion. Yeah, because you really want to offend a lion. Well, there can also be equations with infinite solutions, which are called identities. Anything you plug into these equations will make the equation true. Like the equation 2x plus 1 equals 2x plus 1 is an identity because it'll always be true for any value of x. It's like a mirror. Anything placed in front of the mirror will be reflected back. Conditional equations have a limited number of solutions. These guys are only true when certain values are plugged in. So the equation 2x equals 6 is limited because it'll only work when x is 3. No other value will make the equation true. It'd be like saying only zebras are acceptable for tourists and no other animals. All right. Well, the important thing is to find out what type of equation you're facing.
Okay, now we're going to practice 3 pretty hard problems together, okay? Let's look at this first one. What value of x makes this equation true? Now, one good way to answer this question is just plug it in the calculator. Plug in 17 for x and see if they're equal to each other. Another way to do it is to just solve for x, but boy, is this a long problem. Okay. Okay, so this is the original problem. So the first thing we're going to do is we're going to use distributive property. So we're going to multiply 3 times x and 3 times negative 6. And we're going to multiply 5 times 2x and 5 times 1. The next thing we're going to do, we already used distributive property, is we're going to combine the like terms. So 3x minus 8x is negative 5x, and negative 2 plus 5 is 3. So we're combining like terms. We're combining the coefficients on the left side, and we're combining the constants on the right side. Okay, now that we've combined like terms, now we have to get the variables on each side. So we have to subtract 5x. Add 5x to this side and add 5x to the other side. So I added 5x. Now I cross this out. We're left with negative 18 is equal to 3 plus 15x. Now we need to get rid of the constant. The constant needs to move to the other side. Okay, and the final thing we have to do is divide by 15, but notice this is going to be a decimal. And it's negative 1.4. So the answer is C. The answer is negative 1.4. Now we need to solve for m for this one. This one also is a decimal. Okay, so here's the question. I went ahead, I solved this using fractions, but it's so cumbersome that I think it's just easier to solve this using decimals. So go ahead, before we use distributive properly, let's change these numbers to a decimal. 3 divided by 5 is 0.6, and 6 divided by 5 is 1.2. So let's make them decimals, and we're just going to use our calculator to solve this problem. Okay, I used distributive property. I multiplied 7 times 2m, and I multiplied 7 times negative 7, and I multiplied 1.2 times 4 and 1.2 times negative 3. Now, next thing I have to do is I have to bring the m's to the same side. So I'm going to add 3.6 to both sides. Now I have to get rid of the constant that's by the m. So the constant that's by the m is negative 7. Last thing I have to do is divide by 17. So the answer is 0.69. this is what you write in the box. You write 0.69 in the box. Now, for the next problem, I would like you to take 2 minutes and solve this problem first, and then I'll walk you through how to finish it. So go ahead and solve the problem. Okay, if you have not finished solving the problem, pause the video. Okay, so when you solve the problem, you get the answer x is equal to 4. So what we're going to do is we're going to substitute 4 for x, evaluate this, and then get the answer for k. So I substituted 4 for x. So this is 4 times 4, and this is 6 times 4. And when I solved it, I got k is equal to 43. Now, your classwork is not even close to as difficult as this, but if you just watch me solve the problem, but you didn't actually solve the problems yourself, go ahead and rewind this and solve the problems. Solve some of the problems that I showed you how to solve. Now, the students who take the live class, now the students who take the live class, they're doing their vocabulary and their math assignment during class. So they just finished their vocabulary assignment, and right now I'm going to give them the quizzes code. But since you're watching the pre-recorded class, I want you to go ahead and do the line paper assignment. You can email me if you have any questions, and I will answer your email. In addition, I will have office hours on Thursday from 11 to 1. See you next week.